my dear students. We are back for another session of Mathematics and with me, your teacher, Mr. Pineda. So the arithmetic sequence. So here we have to deal with the definition and identifying arithmetic sequences. And let us start with the definition. So an arithmetic sequence is a sequence where each new term after the first term is found by adding a constant number to the preceding number. The constant number is called the common difference. So here is an example of arithmetic sequence. So let us consider this problem first. Suppose you have started a newspaper subscription on the 5th of September and the newspaper delivery is every other day, even on Sundays. So our goal is to write a complete list of days that you would expect the newspaper delivery. So since that you have started the newspaper subscription on the 5th of September, then you would expect that the delivery man will appear on the 5th of September. Since the mode of delivery is every other day, then you would expect that the delivery would come on the day after the next, which is supposed to be the 7th of December. So followed by the 9th, the 11th, the 13th, 15th, 17th. So let us write the next year. So the 19th of September, 21. So as of now, you have noticed that there is a certain pattern for this particular problem, for which here you would notice that all of these numbers are odd numbers. So let us continue. After 21, we have the 23. So we have 25, 27, 29. So since there are only 30 days for December, then we will not have a 31 here. So here's the list of days that you would expect the newspaper delivery. So it is a sequence because based on the definition of a sequence, we can easily come up with the next number after the first by adding a certain number. For which here, you will notice that we can easily come up with the number 7 by adding a 2 to 5. So if we add a 2 to 5, we get the 7. So we just merely have to look whether this particular pattern applies for the rest of the numbers. And if we use the 7 this time, adding a 2, then we get the next number 9. And if we do the same for the rest of the numbers, then we will be getting all of the numbers that we have listed so far. So based on the definition, so this number that we have used, which appears to be constant, is what we call the common difference. So you may say that the common difference for this arithmetic sequence is the positive. So anyway, the common difference is usually noted as D. So we can also say that D is equal to 2. So this is an example of an arithmetic sequence. So let us proceed with identifying arithmetic sequences. So here are some examples. So our goal is to identify if the sequence is an arithmetic sequence, and we need to indicate the common difference if the sequence is an arithmetic sequence. So based on the definition, we must have a constant number being added to the preceding number so that we get the next succeeding numbers. And we call that the common difference. So here we only need to check whether there is a common difference between the pair of terms. So looking at our negative 4 and 1, so difference means we need to perform a subtraction. So here we have a 1, and if we subtract a negative 4, from which then we get a positive 5. So if you still need to revisit your basics in operations like subtraction of integers, I have a dedicated video for which, so I suggest that you have to visit that first before moving on to this lesson. So let us check whether this pair of numbers, 1 and 6, gives us the same difference of 5. So having our 6 minus 1, which gives us a 5 as well. Now we also need to check whether 11 and 6 gives us a 5. So having the subtraction be 11 minus 6, so that gives us a difference of 5. So we call this a common difference because all of these differences or those corresponding pair of consecutive terms are all the same, which is equal to 5. So there is a common difference. So we say that this is an example of an arithmetic sequence whose common difference is equal to 5. So let us move on to the next. So here we need to check whether this term suggests an arithmetic sequence. So just like our previous example, we need to know first whether the differences between the pair of consecutive terms are all the same. So with that, we say if there is a common difference, then this is an arithmetic sequence. So having our 1 minus negative 3, we have this b equal to 4, while having 5 minus 1, we also have this b equal to 4, while 8 minus 5 only gives us 3. So at this point, you will notice that 4 and 3 are not the same. So this is not an example of an arithmetic sequence. And let us proceed with the next. So here we need to check whether there is a common difference between the pair of consecutive terms. Having our 7 minus 7, which gives us 0. So having this pair 7 minus 7, which gives us another 0. And for the next, we also have a difference of 0. So having this common difference of 0, then we can say that this is an example of an arithmetic sequence. So let us have another one. So let us proceed directly with the subtraction of negative 1 minus 3. So here we have a negative 4. So while negative 5 minus negative 1, it also gives us a negative 4. So negative 9 minus negative 5 also gives us a negative 4. Since all of these differences are the same, then the common difference is equal to negative. Hence, this is an example of an arithmetic sequence. And let us consider other problems related to arithmetic sequences. So here we have, for our direction, you need to answer each problem related to arithmetic sequence, and you need to show your solutions if necessary. So here is our question. What is the next term in the arithmetic sequence? So since the problem states that this is an arithmetic sequence, then we must have a common difference. So to check our common difference, then we may use the second term and the first term. So having the difference of these two terms, we can, so let me do some scratch work here. So we have the negative 4 minus negative 13 for our common difference, which is equal to 9. Our common difference is equal to 9. So now that we have our common difference, then we just have to add this common difference to that 14 so that we get the next term. So 14 plus 9 gives us 23. So that means our answer would be 23. So the next term is 23. So next, what are the next two terms of the arithmetic sequence? So here we are asked of the next two terms. So again, we must use a sub 2 minus a sub 1 to give us the common difference. Our a sub 2 is negative 3, while the a sub 1 is 7. So negative 3 minus 7 gives us negative 10. And the same with our previous example, since the last number in the sequence here is negative 23, then we may get the next term by adding the common difference of negative 10, which gives us a negative 33. So that means the next term is negative 33. But the question asks us to find the next two terms. So we must continue doing this time using the negative 33 plus the common difference of negative 10, which gives us negative 43. So the next two terms are negative 33 and negative 43.